Welcome to Study Loop.
So to find out the net ionic equation for this reaction, first you have to write down the balanced equation for this reaction. And if we just write down the balanced equation directly, it will be H2C4 H6O6 in aqueous form will react with 2 sodium hydroxide in aqueous form to give us 2H2O, which is liquid, plus Na2C4H6O6, which is also aqueous. Now from here we have to break down the strong electrolytes into ions. So here our only strong electrolyte is sodium hydroxide, which is a strong base, and this tartaric acid being a weak acid, it is a weak electrolyte and will not be um, completely dissociated into its ions. So we'll write down in its molecular form for our overall ionic equation H2C4H6O6. So although the formula in the book is given for tartaric acid as H2C4H4O6, but the actual formula um, contains 6 hydrogen, not 4. So being a weak electrolyte will be in the molecular form, then the sodium hydroxide will be broken into 2Na plus 2OH minus, and this will give us, so H2O being the liquid will be in the molecular form, and this one is our strong electrolyte, which is that means we will write down in ionic form 2Na plus C4H6O6 minus. So from here we can cut down our spectator ion, which is sodium. So you can cut the sodium ions, and the rest will be our um, net ionic equation. So if we just remove this sodium from its side, the remaining equation will be our net ionic equation. So this is our net ionic equation. Now, so in the second part of this problem, we have to find out the molarity of the tartaric acid. So to do that, first you have to find out the number of moles of the sodium hydroxide given from its molarity and volume. So number of moles of sodium hydroxide is the molarity times volumes, and the molarity is 0.2500 molar or mole per liter times the volume, which is 24.65 times 10 to the power minus 3 liter, and this will give us a value of 6.16 times 10 to the power minus 3 mole. Now from the balanced equation we can see that 2 mole sodium hydroxide reacts with 1 mole of the tartaric acid. So we can write down 2 mole of our base react with 1 mole acid. That means this much mole of base, which is sodium hydroxide, will give us 1 over 2 times 6.16 times 10 to the power minus 3 mole, which is equal to 3.08 times 10 to the power minus 3 mole. So this is the number of mole of our tartaric acid. Now we know the number of moles of the acid, and we are given the volume of the acid. So from there we can easily find out the molarity of the acid. So the molarity of H2C4 H6O6 will be the number of moles over volume. The number of moles is 3.08 times 10 to the power minus 3 mole over 50 milliliter, or 50 times 10 to the power minus 3 liter, and this will give us a value of 0.06 mole per liter or molar. So this is the molarity of the tartaric acid in the given solution.